All right, let's begin. Welcome back to the Magic Forge. Thank you for checking us out on this video and this stream on Twitch. If you've been enjoying what you've been seeing, you like what we've been doing, definitely please like and subscribe. Let's shoot for the unrealistic goal of 1 million subscribers by the end of 2026. Come on, nothing's impossible. Let's just try for it. What the heck, it's not going to hurt anything. Let's just go for it. Hit that bell icon on YouTube to be notified of any time we upload new videos. Definitely if you have been enjoying what we've been doing. So today, it's a joyous day. The PCBs did arrive from JLC PCB. Now again, I'm going to stress, I'm not sponsored by them. I received no money, no funding. They're just one company I like to use. They're reliable. So I have nothing opposed, nothing against, at least saying that, even though I'm not sponsored, give credit where credit is due. They're a good company to work with. Prices are affordable, and it's not their fault that we have people putting tariffs on anything that moves. Put tariffs on an island of penguins, but hey, it's not for me to judge, right? So yeah, it's not JLC's PCB's fault that there are tariffs on their stuff coming in. So unfortunately, but everything else, their prices are pretty good for what you get. Really good, and their quality is really high. So the boards have come in. It is time to check these guys in. So what we're going to do is a few little things. Not only are we going to check them in, but one of the things I want to do is kind of update the label here. And we're going to go ahead and I kind of think, maybe we should have like a PO line. Just because. There, keyboard input, text, PO number, value required, apply, close. We're going to save that. Oh. So that'll be the PO number. That way we can just go ahead and track it on the label. It's, it's one little extra thing to punch in, but it's not going to hurt. Again, that's, you'll enter it and then print it out on the next license or the next labels without having to change a thing. And I think one of the things I want to do, let me drag that off here real quick. I want to do one quick search. Because if I remember right, PCBs are technically the range varies depending on the manufacturing. So PCBs can technically have an MSL rating. Sometimes you're better off treating them as if they're 3, around there if I remember right. But I've never really had a problem, so I'm not going to worry about that. So if we remember our processes, so we've received the boards. So we have incoming inspection we'll have to take care of. We got to get them checked into Odo, basically. Get labels on everything. And, make sure we're following this. And then if you remember the mistake I made, that they're 1 ounce copper instead of 2 ounce copper, we will make sure we have basically the approval to use them. And I was thinking like a way we can do that, that way it stays with them instead of a sheet of paper. We'll just make an approval label. We'll just use the, we'll kind of save this label into the label directory. We'll kind of rewrite it for, kind of re-engineer it for the non-conforming materials use of, approval. And we'll go from there. So the first things I'm sure everybody wants to see is the PCBs. Because I know I really want to see them. I mean, I've already seen them, but, let's be real here. This isn't an unboxing channel, so I've already looked at them. I just want to kind of do the reveal on stream. I did get a ring light for my camera. I kind of tested some things out. It definitely gets rid of most of the shadows, but you know, some more details and kinks to work out, but I think it does look a little bit better. And the way I've kind of got things rigged, I've got an adjustable arm that the camera is actually stuck to, the webcam, so I can kind of move things around a little bit. So I'm going to try not making anybody sick. I think it might be easier for me to do the assembly videos with something like this. You know, we'll work at all the details and figure it all out. I'm still working out the kinks in Odo or OBS Studio and with everything I've got. But I wanted to get it to work for our processes and for what we're trying to do. That's gonna be a process in itself, because it's not just like a generic, you know, it's not just like a channel where I can just use my phone or whatever and I'm, you know, recording myself and my computer screen. There's other things I want to be able to do. I'll be jumping between, you know, my office and the workshop for some videos to do the building and assembly and bench testing and stuff. So I'll have to move everything in there until I can get more equipment and get it better set up so I can streamline. But for now, we'll just have to deal with what we have to deal with. And so, you know, I'll be moving the camera, so I apologize if it makes anybody sick or motion sickness. But let's switch over to the webcam. All right, so I'm going to kind of pull back a little bit here. Mind the cardboard all over my floor in my office. I've been doing some cleaning, and my cats really enjoy playing with cardboard boxes and chewing them up. And mind all the cat fur. We've got 5 cats and they love leaving fur. So things are kind of sideways. So my hands are, you know, coming in like this from the side. It's just because I have things set up. This is the box the PCBs came in. The other 2 boxes below it are the stencils, the full frame stencils. And we'll get to that. But first we're going to open up the PCBs. And I'll keep the box that they came in, and that's what I'm going to stick the label to. So I've got to admit, these came out looking pretty good. All right, try to get it in shot. Yeah, you're going to get the reflection of the ring light. I'm sorry for that, but they are glossy instead of matte. Gold immersion nickel plating on the pads and everything. So that's our back side with our part number revision right there and the copper layer. Trying to get my orientation right. So yeah. So we've got our PCBs. All right. So again, not to make anybody sick. Try to get it out of the reflection. So according to our process, and we could really look at our incoming inspection process. Let's see here. Let me pull up incoming inspection. So basically, we need to check out. Switch over to the computer real quick. There's going to be some switching back and forth again. I'm not trying to make anybody sick. It's just, you know. So according to what we've got, we have basically dimensional inspection. So we'll make sure the board matches the within the tolerance of the size that we expect, thickness, inspect the solder mask, so screen, drill alignment, warpage, kind of look at all that. We don't have like warpage gauges or anything. Doesn't like that, so I'll fix it. I'll get rid of that. So we got that. So we will go to KiCad real quick. And fortunately enough, we have our dimensions outlined here. 120 millimeters long, 85 millimeters wide. And I have a ruler that we're going to check that against. And yes, to answer any questions that anybody might have, rulers that are used to measure things like this for a production device would technically get calibrated. So All right, 0, 0, about 120 millimeters. That checks. And we are at 85 millimeters. So that checks, that tracks. Grab my handy dandy caliper. Yeah. So you have a tolerance of 0.254 millimeters. Yeah, so we're good. Even a tolerance of 0.127, we're still good for a 1.6 millimeter. That's not a critical dimension for our project. Sometimes you have if you're doing a project for a specific customer, thickness could be a critical dimension, depending if they've got an enclosure designed already, or if you're replacing an existing board. But if it's a project like this, it's fresh off the bat, nothing's been perfectly defined or predefined, then it's pretty much whatever you want it to be. And 1.6 millimeters is not critical. So if we go back to the PCB again, I've also got the hole centers tagged in too. So we'll kind of, we'll just kind of compare them just to make sure. So center, long ways. Yeah, that looks good to me. And 75 millimeters, because again, you still have to allow tolerances. And that looks good to me. I know, hard to convey. Yeah. Yeah, so that looks about right. So dimensionally, that's right. All the dimensions. Again, we don't have a warpage gauge, but you know, standing on edge and looking at it, like how carpenters will look down a 2x4 or other piece of wood, you know, a plank or something to check for warpage, bendage, you know, anything out of spec. You could do the same thing. You know, you're just looking to make sure it's a nice, clean plane with no bending or, you know, twisting or any weird wavy patterns in it. You're just looking for as flat and straight as possible. And this looks fine. Everything here looks fine. What I like about companies like JLC PCB and PCBWay is they actually route the edges so they're nice and smooth and clean, nice factory clean edge. And I do like that. And it's also an IPC requirement for printed circuit boards. You shouldn't have any basically fiber threads hanging off, or it shouldn't be extremely rough. Definitely the threads, because those can be considered debris to be contaminants. So one of the things we want to do with a new PCB when we get it in is at least spot check the things we can, like the silk screen. You know, you have the drawing or the PCB layout file or a render of it. So like what I can do here is kind of do a render. Let me switch back over to the computer real quick. So I can have a render, and at some point maybe have a document, like a little packet, specification packet for this board. That'll have all that for incoming inspection, things we can do. But so you have the silk screen here you can compare it to. I know it's not showing the 3D models for all the parts, and that's because to deal with a problem of pathing, of too many characters in the path name, I had to kind of put it in a new directory, so now I have to go through and fix all the models again. So I wish I could create like a relative path for the models for their the footprints. That's why I'd rather have the STL files, actually the model files, actually embedded in the footprint themselves rather than being linked to an external file. Because then it doesn't matter. They basically, the models follow the footprints. That was one of my big complaints about KiCad, is the other ones, the models get embedded into the footprint file itself, and they follow it no matter where the footprint goes. With KiCad, you've got to have a separate directory, so you have to fix your file paths every time you need to move anything. Typically, though, in a real environment, you're not going to be moving your files. Once you get things located and situated, you're probably never going to move them. That's why you're better off setting yourself up right off the bat. So we've got that. We've got that to reference our silk screen. We just want to kind of make sure that it's going to look as good or as close as you can. You're not going to have the exact same resolution because that all depends on the equipment the manufacturing house uses. But you're going to be darn close. Yeah, all right. This webcam's not quite playing nice, but it's okay, I guess. So visual inspection of the silk screen, it looks good. The dimensionals are fine. Nothing looks smudged or blurred. Even though they're small, I can still read the test point designators. So that's fine. That's perfectly acceptable. Now, one of the other things that we need to do is just as best as we can a spot check of the basically you want to check, make sure there's no resistance shorts, at least in the power plane. So I'm going to take my nice little handheld multimeter, my nice little Agilent here, and what we're going to do is, so I'm going to kind of back this up a little bit, and I'm going to try to get it so you can watch it without the glare. So yeah, so there's a short there. So we know from the drawing and from laying this out not too long ago, so this would be a test point for 3.3. That's a test point for 5 volts, and the one in the middle is for ground. So the main thing we want to do is make sure it's an open circuit. Yeah, make sure you're not shorting out between. Make sure that the meter's still working right. It is. So we can even go into where it beeps. Yeah, we're fine. No shorts, which is good. That's about the only thing you can test for without doing a track for track. You just want to make sure your power planes aren't shortened straight to ground, because that would be a critical failure right off the bat in the board. And that is definitely a major fail. And that does happen. But we're good there. So get the meter out of the way. I'm done with it. It's done its job. So what I'm going to do, move the ruler out of the way. Again, I only have one camera, and with what we're trying to do with the video channel, with the videos and everything, I have to kind of bounce between a bunch of different things at once, so bear with me. So because we understand it's going to be a non-conforming board because of the 1 ounce copper versus the 2 ounce copper, at least as we spec'd in this ordering, additional testing may show that 1 ounce is fine, because we're going to put this guy through the ringer, and if 1 ounce is fine, we'll just change the spec and we'll stick with 1 ounce. So I'm going to switch back to the desktop. Is again right here, this big thermal mass. That's really what the 2 ounce copper is for, is just to really help add the thermal mass to pull the heat out of this guy. Some power supply ICs will tell you to use 2 ounce copper, but these guys don't. It's really this guy that the data sheet's calling for 2 ounce. So even though we've got that non-conformity, we're going to be okay with it, because I think the design is going to be fine. Because if I remember right, in the design that I had done prior for the other project, 1 ounce copper was fine for it, and it was fine. So I'm going to close this out. Actually, while I'm here, I'm not going to worry about the 3 models. I'm going to File, export the current view as a JPEG. We're going to throw it out here. The reason this will come in later, but since I'm here, I might as well go ahead and do it. 01 for revision 1. All right, and I'm going to save that as a JPEG because what we'll be able to do then is pull that into future documentation, especially when we go to to refer to this photo. We're going to modify it to like indicate where to put like thermocouple probes and stuff for the deep testing. So we can close that. We don't need that. We're okay with this. We checked our measurements. So we can close that out. So one of the things we need to do then is, before we get too far ahead of ourselves, so we have this guy. Expected date. All right. And that guy should be P's quadruple 01. P41. And then they came in today. All right. Internal part number. Again, we can pull that from Odo. Open that new tab. It's much easier. Copy that. Okay, so visually it passed. Electrically, we're going to say it passed because it passed the resistance test. Dimensions, it passed. So we might have to add this, put a note field in here for the NCM. So let's go and do that right now. Let's go and fix this log. Right, and then notes. That. And delete that. Just keep it in line. Oh yeah, I don't want to forget to format the cells with the border. Okay, all right. So because there's going to be an NCM on this, so we have to, so it's non-conforming, so it's going to be a yes. NCM number, we should have it in our, let's see here, NCM. So I'm just going to copy and paste that to here. We're going to generate the month, day, year. And there's going to be 01. All right. I'm not going to worry about fixing the row height or anything, or the row height or anything. I don't really care. Let's see, PCB was at 2 ounce copper and was ordered at 1 copper. All right, cancel. All right, so that is that NCM. That's just a note that we're passing here. So then let's just go and copy this. Go over to the non-conforming log. All right, SD. All right, POP1. Internal part number. Lot number would be quantity. I think I ordered 10 boards. 3. Yeah, 10. 10. Issue described. And we're going to go here. Disposition. So, use as is. Use full quantity as is. So we now have a non-conforming materials log. So the reason this is different, why we're duplicating, that's unfortunately one of the things that has to happen. For one thing, because different departments, different people are involved with this. Like, so you would have like a receiver or a receiving technician, somebody handle the incoming inspection, and then somebody else handles dispositions and quality assurance. And sometimes they're not the same people, and so a customer may want to just look at this log to see how things are resolved. So we may add a notes field, but we could, even right now, just the disposition. We can put a notes field in there, if we think the need arises to justify the disposition. But usually that's not going to be a problem. Usually you have other supporting evidence to support a disposition. Or you can back up your claim. Like, for now, for this is because this is an initial prototype batch build. We don't really care. It's fine. And experience shows us it'll be fine. So what we need to do now is... So we're going to go and leave that up. So like I was saying. So now we need to... we're going to go ahead and file. Save as. We're going to call this NCM label. All right, part number. Let's see, lot number. Don't really need that. Don't really need that. Don't really need that. Don't need that. Don't need that. Don't need that. Data receipt almost doesn't matter, but PO number kind of does. Yeah. Just gotta drag all these guys down. NCM. So one of the things, for one thing, I want to kind of, make that as noticeable as possible. Non-conforming materials. So one of the things that you could do is through a custom label company, see if you can get these labels printed in red or manufactured in red like this. That way you can run them through the thermal. So the direct thermal, if you can get them in colors like that, that'd be great, because then you do all these color coded labeling for your products and have, basically a red tag for the labels. But that's another reason we're doing this, is to have an additional label go with the product. Kind of down here. Not perfect. Stays with the items. disposition. All right. We can always work on the wording later. That isn't a big deal. So, this is getting all messy. Okay, here we go. All right. All right. So, we're going to call NCM number. NCM number. So the part number, we definitely need the PO number it came in on, the lot number, if you have it. So we're going to throw that right here. Let's see here. Disposition. So we're going to get this line here. It's going to be variable keyboard input. Position. Hopefully it'll be long enough. Okay. We can always change that out. NCM number, blah, 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 disposition. So this will be another label that we'll have to print out for the parts. So we're going to save this. So what we're going to do is we're going to print it. All right. NCM number, part number. P1, lot number, and use full quantity first. All right. So that's going on the PCBs. I'm going to shoot out 2 of these. Oh, I should have done it there, but well. Print out 2 of these little guys. So I'm going to show you where we're going to stick them. I'm sure my wife had an opinion on that. But so since we're keeping this little bag, show you what they look like too. So basically that's, you get the gist, the whole reason for this. So stick one on the bag. This way nobody has any questions. I'm just knocking stuff down. So we'll have the label on the box. As I'm keeping the box, keeping these guys together. So that won't be a problem. So let's go back to here. So we can do that. Go back to open our product label that we've got to now fill out. So we can close this guy. We've got a disposition. We've got the label already made for it. Technically, the quality manager would do that. Print out the label. They'd handle it. But again, I'm everything. So unfortunately, I'm the one that has to handle all that. So we're going to print. Part number, P001, date of receipt. Lot number. Actually, let me see. Do they have their production code on here? Sometimes they do, sometimes they don't. No, they didn't. Yeah, you can always request a manufacturer put like a lot number on your products. Date code. There's no date code. SMT-1. That's just the general location. We're going to call it that. So we have our label. We're going to, again, shoot out 2 copies. Because we're going to basically apply these to, still on the box. Yeah, let's switch back over to the webcam. Woo! Let's drive everybody crazy. So for this, we'll put this up here. And on the PCBs, come here, label. Yeah, I'm gonna have to rethink my setup, but it is what it is, and it'll work. It is working just fine for what we're trying to do right now. A little bit cumbersome, but I don't care. It's fine. So we'll put this guy up here. So we got our board. I'm going to keep this. I'm going to keep one board free for a moment. Move this guy out of the way. And we're going to go ahead and basically keep the labels open. I'm going to go to the Odo. Close out there. So now we're going to go to the stencils. I'm going to kind of zoom this out again. Forgive any cat fur or cardboard pieces. My cats love it. So I'm going to move one box out of the way for now. And an unboxing. And you'll see why I like getting the stencils, especially in the frames. And I save the boxes. I store the stencils in them. So here we go. Oh boy, that reflection's horrible. Not much I can do about it though. So you have an aluminum framed stencil. And I don't know if I brought this up. I'm not as prepared as I thought I would be. Oh no. All right, so I don't know if I showed this or what. My fault if I didn't, or I did. I apologize for doubling things. So the reason I get the full frame stencils is because I have one of these little guys. Awesome. Awesome to work with. So the stencil mounts up in here in this assembly, and then the frame helps hold it flat. You have these jigs right here to help, you can adjust to hold the boards. And then you've got these little dials on the sides here. Let's see if there's and this is a kit too. So yeah, I don't even barely see them, but these dials, they adjust your skew and your offset to the stencil. So they're really great minor adjustments. And I really like it. And this kit comes with a stencil squeegee, an SMT squeegee. This beats hands down using a credit card or a plastic squeegee that you find. Hands down. It comes with the nice stainless butter knife for mixing solder paste. Excellent for mixing solder paste and pulling it out of the jar. And then it comes with all the jig fixings and stuff. Your screws, your depth pins that get mounted into these little fixtures right here to basically, they're spaced appropriately and sized appropriately to properly hold your PCB. So really cool. But this guy right here, the squeegee, that just definitely saves the time. So I'm just going to show you this stuff. So this stuff is right here is a solder paste I've been using recently. This Wonderway solder paste. I prefer other brands, but for how this stuff actually works pretty good. Again, I'm not sponsored or, you know, I don't receive royalties or anything. These are just products I use. This stuff's really good. I've had success with every board I've built with this stuff. So I have nothing against it. And the cans, the little plastic cans are perfect, because if you've ever done this before and you've tried squeezing out solder paste out of a syringe, for one thing, it's difficult, and then you're never sticking that solder paste back in the syringe. So you're always going to waste some. This allows you to at least reuse your extra paste, and put it back in the container. Now, it's a good practice that in the long run, once you start using this and having empty containers, you don't mix old paste in with new. So what you'll do is, when you're done doing your reflow for a day, let's say you have an empty one of these, you would mark it like old or used. So when you clean up like your squeegee, your stencil and everything, you put the old paste in here, and then when you go to start your new day or your new run of batch production, you pull a little bit of solder paste out of the new jar and mix it with the old stuff. You don't go the other way. And this helps keep contamination to a minimum on fresh solder paste. That's actually manufacturer recommended. I don't know if these guys really recommend it, but the big like AIM and all them, they do recommend doing it that way to just prevent contamination in your larger container, because you can get these in really large containers, but they are expensive because they are an alloy, and it's really dependent on the current cost of the metals and everything else. So another thing I want to mention, SMT. I'm just bringing this up. So again, only because, so I use these guys. Now, the reason I do is you do not want to use alcohol to try to clean flux or paste or anything off of a board. Alcohol will chemically react with some of the chemical compounds in flux, and it can actually make it worse. It can actually leave a sticky, gooey mess behind that does not clean that easy. Unfortunately, that's just the way it goes. That's a common mistake that new electronics, new solderers and stuff do, new assembly techs, is they go for the alcohol, the isopropyl alcohol. Do not use it when you're trying to clean solder paste or any of that off. You want to use a chemical for doing that. So this is a stencil cleaner wipes. It's also great for wiping solder paste off of a board that hasn't been populated yet, or if you want to clean it off, and that way you can just use the board again. And then for actual flux, if you're trying to use it, like say if you're using no clean flux and you want to clean that off, there's a chemical compound called Flux Off for cleaning that. I think that's the exact name of it. Yeah, Flux Off. So basically you want to use this, or this flux remover, these kind of products, because they won't chemically react with the flux and actually make the problem worse. These are actually designed to remove solder flux. So I just want to make that clear. And then another thing, and I'll reiterate when we actually go to build, safety comes first. This stuff does give off fumes, so you want ventilation. You want to be able to, if you have a reflow oven, you want to try to vent outside or at least keep airflow. Don't stick around in the room, with bad fumes. It gets gross and nasty after a while. And lead-free flux and stuff, it smells and it stinks, and honestly, it can leave a nasty taste in your mouth too. I'm not kidding. So just be mindful. You want ventilation. You don't want to be sealed up in a little closet somewhere. I've got the exhaust output on my SMT reflow oven. So I've got, one of these little guys. I'm eventually going to buy a nicer setup. I'm going to have a nicer rig, a nicer setup for reflow. But for basic work, these little guys right here, ignore all the fancy labeling. They're all pretty much the same. the T962. So the one I have, I made sure has an exhaust port on the back, and I've got it exhausted outside of the workshop through a dryer vent that I installed. And then when I'm done reflowing, I actually have a boost fan I turn on to help pull the fumes in the air out. But yeah, so over time, I want to get something like this, like an actual conveyor reflow oven, multi-zones rather than just one. These have a tendency to overcook the boards. They get a little toasty, but they work for a small batch and prototypes. But again, something with an actual conveyor line and a couple of zones is what I'll be looking to do down the road for myself. But that is that spiel. So I just wanted to go over that. So we're going to check over the stencil. And why I showed you why I left the board out. So we're going back over to the camera again. Sorry for the glare. So this, I chose the electro polishing option. You really can't see that. This might make it worse. Oh God, that's hideous. Kick up the brightness. That just really gets that glow. That camera hates that glow off of that ring light coming off that. So I apologize for that. I really do. But so hopefully maybe once I pull this protective film off. So this is extremely shiny because I pay for the extra electro polishing. Yeah, it could be a waste. You don't have to, especially for prototype batch. But to me, after doing this enough, for one thing, there's called breakaway. So basically, when you put your paste on, let's get this protective film off. This is always so satisfying to pull off. I did save this for my viewers here. Oh, yeah. So satisfying. So you really can't see them too well because this ring light. Let me see if I turn the light off, how bad it looks. Again, I'm sorry. Okay, now it's just reflecting everything else. Jesus Christ, I can't win. All right. So, okay. Wow. Let's see if I can. Yeah, I will try to figure out how to do this better. But this is just such a shiny reflective surface. So, wow. Doesn't really help much. So you've got the orifices. So like these guys. So those would be for like resistors or caps. So your breakaway is when you go to remove the stencil from the board after running the paste. It's basically, it leaves a nice clean, basically break that the stencil breaks cleanly from the board and it leaves the solder paste behind. Because what you don't want is, as you're pulling the stencil away from the board, the solder paste to stick to it and lift off of the PCB. That's what you don't want. So that's your breakaway. And then the electro polishing also helps, which is cleaning all the extra residue off with those wipes. These stencils clean like a champ. And they even put the protective film on the bottom. So that's another thing I like about this, about the way this company works. Here we go. Satisfying film removal. Yeah. And then we go to build. You'll see everything better. So one thing, so I know this is the bottom stencil because of the patterns and stuff here. So I like taking the PCB. Now this is going to be a pain in the butt to show on camera, but I will try to do the best I can. So one of the things I like to do, might be easier. No, wait a minute. Okay, that's why. All right. Here we go. Pain in the booty. All right, one of the things I like to do is I just like to Oh my God. Oh no. Oh. Okay, I think I see some. No, they're there. It's just really hard to see through this. It's going to be a lot easier to see, but my spot checking. So what I'm just trying to do is I'm just kind of double check, just kind of check the initial alignment to make sure the parts actually do line up, the pads. There we go. Oh, yeah. I don't know if you could see that, but see the gold enig through the orifices. Yeah. So basically what I do is I just spot a line to make sure the stencil is right. Because the good thing is, if the board's good and they just mess up on the stencil, you can just get a new stencil. Call the vendor, complain, let them know that there's something wrong with the stencil. And they're really good. Like I said, JLC PCB, I've never had a problem. Any of the issues I've had with them are my own doing by my own hands. So I will never, so far nothing I've had from them is because of something they did. So that is the bottom side stencil. So I'm going to turn that off for a moment. We're going to get this part number. Now that might be a problem to print. If it is, we'll fix it. It's on the same PO. No, it'll fit. Same there, same there. Same MSL. So yeah, we're going to shoot 2 labels. Oh, they printed out pretty good. So I'm going to come back here and I'll show you. So I don't really care. I'm not really concerned too much of how this is going to go in, but it's in the, if that's going to be the top or, the bottom, orientation in the actual printing device, but it's going to be basically the short edge. So the long edge, what I'm going to do is take one of the product labels and stick it on here on the stencil itself. And then we're going to put the stencil back in the box so it doesn't get damaged that easy and my cats don't have a heyday with it. We're going to close the box back up because we do reuse these. And then what I like to do is so on one of the short edges, usually they have their label. So I'm going to put our product label kind of on that edge too, the same edge, just to be consistent and to kind of make it easier because I have a shelf I store my stencils on, and now I have my part number and the bottom. Sorry again. So the bottom, so I know that if I'm working on that project, this is the bottom. Set that guy aside. And we get the double luxury of the top SMT stencil. So again, the film, same thing. We're gonna pull that satisfying film off. Oh, so ASMR. Who doesn't like pulling this film off stuff? This stuff. There we go. We got the bottom. Well, this is the top. Same thing applies. Grab the PCB. You can definitely tell, that's the ESP32. Same thing. We're going to just kind of test fit the PCB underneath. Actually, gold enig, the gold immersion enig, immersion gold, is much easier to do this test with because Hazel looks very similar in color to the actual stencil material, so sometimes it's hard to tell. But this gold really stands out, the gold immersion. And honestly, I prefer to do the immersion gold. It's just a little bit more expensive. So we know that is the part number for that is the exact same thing. It just says top. and I'm just going to manually change it. It's all on the same PO. We're going to shoot up 2 copies of the label. And it's amazing, this process, everything we've done with just receiving the PCBs, have taken almost pretty much the entire video, the entire hour. But it's a process. Everything's a process. It would probably have taken me less time to do this if I wasn't trying to record a video and try to be more specific and detail oriented and show you guys some of the stuff, you know, some other stuff, and talk about like the safety and stuff. But again, when we actually go to build, hopefully I can have everything set up and you can get a better view of the process and what's actually involved. At least to do this, you know, without an assembler or machines to do it for you. So we're going to get this stencil packed away in its box to protect it. Find the edge with the factory label. Grab our product label. And yes, these are inventory items because when you grow your business, they are considered you know, something that you would have to pay taxes on at least the first year. And you do have to account for the inventory. So you do have to inventory these and handle them through the proper processes if they need to be scrapped out or anything. So if there's a revision change. So the cool thing is, if we rev the board, let's say we're just adding the test points, but we don't move any SMT parts. If they stay exactly where they've been, we won't have to order new stencils. We can just keep these stencils because like the test points are through hole. That won't affect anything. Yeah, ignore this little tray table. It's seen a lot of use for painting and everything else. I don't, you know, I'm not really into curating the perfect operational environment because that's not how life works. I've seen those YouTube channels where everything looks perfect and clean and mint and fresh, and I don't buy it for a minute. I'm just going to be flat on honest. I think it's all too curated, too neat, too clean. That's not how life is. So we've got this. We've got our label. Close that. Now we've got this. We'll close that. Now what we're going to do is receive. So we've got them. Yeah, it's going to bark at me, but I don't care. Because I was kind of expecting them then, but I think they got kind of delayed. So we got our stencils, we got all that. We're going to validate. Boom, we've got that. And I think we're going to, let's see what we got here. Waiting bills. I'm not going to do anything with that because I'm not going to be using Odo. I don't use Odo for any of my accounting yet. Who knows? I could change because there are plugins that you can get to incorporate Odo with QuickBooks and stuff, and Quicken and other stuff. So you never know. So it's cool then if we go here to manufacturing. Now it's going to say the SMT level, all parts are available. So that means we can build this guy. All the parts are green. Now that we got our PCBs in, boom, that's good. And then we've got our parts to do this. So maybe the next video we'll build, maybe the next stream we'll build that. I have no real way of testing it though. So that might be something we might have to do, is develop a little test fixture for this guy, which might involve actually building another board up, another circuit. You never know. We might actually design another PCB, but who knows? I might just throw a PIC on there. Like something like a PIC 16F or something. Because we don't need super advanced functions. Or I can use an ESP32. I can use a C3 Mini or something. Or just one of these ESP32s. I mean, for a little test fixture, I'll see. We could use a PIC or an ESP32 for a little test jig for the fans. That way we can maybe like have serial UART, make sure it speeds up, and you can read the TAC and everything. Who knows? And that's sometimes the things you've got to do if you have a manufacturing environment, is you want to have the proper testing equipment to test the stuff that you're going to be shipping out the door using in production. So that's something I might actually consider, and maybe we'll design that on stream as well. And, you know, it'd be fun to be a low-cost little product, because we could, the low current consumption, we wouldn't need much of a power supply, because we can power that off of a USB, off of a USB port, because that fan's only like, I think 20 milliamps or something like that. It's like nothing. So we can power that. All we need is a 3.3 volt power supply for the ESP32. See, now if I'd be willing to do it with a PIC, the PICs are rated at 5 volts, so we wouldn't have to throw a power supply on there. But I like working with the ESP32s because in some regards a little easier, and I've got a lot of code already validated and working with the PIC. So maybe that's what we'll do. Who knows? We might make a little video, kind of go off to the side, make a couple, like a video off this series into making some of these test fixtures, because it is still important. It's still part of the process. Something I believe is important to do. So we've received all that. So all we have to do is build that up, our fan. I'm hoping maybe Wednesday we can build. I'm going to double check my supplies, because I haven't checked what I have on hand, my solder paste. I want to make sure I have enough. If I have to order more from Amazon or something, I can maybe get it here by Wednesday. Or we might have to wait till Friday or Saturday to build the pilot board. But I'm hoping maybe we can do it Wednesday. So I'll double check everything I have. We can get that tack fan built, get this work order closed. So as far as all that goes, we have all this done. I am done with that. You know, let's go ahead. Let's ignore that. So what we're going to go ahead and do is, should have done this here, but since the do that stencils. Let's go ahead and add these to the incoming inspection, because they are products we checked. Open you up a little bit. Nope. Hello. Open up a little bit more. Stop. There we go. So we're going to say, no. We're going to kind of say pass on this. Because in a way, throwing the PC board up, is that, and because we know the only difference in the part number is top. Boom. Because we put the board up against it, we checked the orifices to make sure that everything lines up. So technically, your dimensional passes. So we're good there. All those parts are checked in. Boom. We have that. We have the non-conforming. All right. So is there anything else we need to cover in this part of the process? Not really. I'm hoping also maybe tomorrow or Wednesday or whenever we go to build the board, I'll have the kind of like the little packet set up, show you everything of that. You know, that way it makes it easier to assemble. That way you don't really need to have a computer handy to cross-reference everything. So we're good there. Good there. Okay, so I think what we're going to do is call this video done. We got our boards, checked them in. We are technically ready to build. I thank you for checking us out and watching this video. I really appreciate it. And for my viewers on Twitch, I really thank you for sticking with this and interacting. It's been a blast so far, and I definitely hope we keep doing this moving forward. So have a good rest of your evening, and I will catch you Wednesday if everything goes well.